Hello, welcome. Let's try to solve a Leetcode problem. 1197 minimum knight moves. So we are giving a knight. So this knight is starting at the position 0 and 0. And we are also having an infinite chessboard with coordinates from negative infinity to positive infinity. So if the board is unlimited, it means this knight normally can jump to any places. Yeah. So we want to return the minimum number of steps needed to move the knights to the square x and y, and this x and y is given. It is like this. So for example, x is 2, y is 1. Yeah, so if the board is unlimited, I mean if the board is really large, normally I think if I use BFS, it should have a time limited exceeded. I don't know. So for example, I'm standing at this position and I can jump. According to the jump, I will jump like horizontally 2 units and vertically 1 unit. It will be like this. If I were to jump horizontally 2 units and vertically 1 unit, I maybe jump to this place. And if the board is unlimited, I don't know how big it is. And if it is a BFS problem, it may have time limited exceeded. So that is why I have to check what is this x and what is this y. Maybe I can use brute force, BFS brute force to solve the problem. Now let's just continue read the problem. So let's check from here. So this x and y, actually it is not unlimited because this number is not so big, and xy is 300. It means 300 minus 300, maybe 600, and 600 times 600. Normally this number is still a small number. If this is it is n square, normally we can solve it. We can use the BFS to find where it is. And now we need to decide what is the next step. As you can see from here, there can be 8 possible moves if it is inside the board. But we don't need to control the board because the testing case is always limited. So we will not control the board, we just need to check where it can jump. And we're gonna, basically BFS can get the fast speed because it will always return the shortest path. And we are also needed to return the minimum steps, and this minimum steps is actually the shortest path because the cost is always 1 or always constant, so we can directly use BFS. We don't need to use the Dijkstra's algorithm. Now let's try to define the BFS to solve the problem. So I need directions. So these directions will be 8 directions. So if I move 2 steps forward horizontally and 1 step vertically, so basically I need to find 8 directions. I think this one might be the difficult part. Actually, it's not so difficult. We just need to find those 8 places. So for example, this one and this position, it is 2 1. So this position is 2 1. So next position is so this position is 1 2. 2 1 1 2, and this position, we need to familiar with the Cartesian coordinate system. So this is gonna be minus 1 2, and this is gonna be minus 2 1. So I just need to finish 1 2 minus 1 2, minus 2 1. So let me just continue. So it is 1 2 minus 1 2 minus 2 1. And for the other 4 directions, we just need to copy and change the we just need to copy it and change the numbers to its opposite. So we're gonna change it like this, and it's gonna be 1 minus 2, and here gonna be 2 minus 1. We just need to use the symmetric point to check it one by one. So now we have the 8 directions, so that will be needed for the BFS. And we also need to have a queue So I'm gonna define a dequeue. So inside it's gonna be my starting port 0, 0, and 0. So the third 0, this 0 is my steps. How many steps do I need? So this is the minimum steps I need to return. I also need a weighted set. Yeah, because in this way, I need to basically run the algorithm n square. N is the length of the square. Basically, it is 600 square or 300 square, because this is also controlled x, absolute of x plus absolute of y less than or equal to 300. So this means that the number can still be smaller. It may be not 600, maybe 300. So anyway, we can solve the problem because the time complexity is okay by using n square, by using BFS. So inside the weighted set, we're going to prepare a set. Inside it's going to be 0, 0. That is just the start from the beginning. Now we can use BFS. So we're going to pop it out. So for RC and step would be q.pop left. Yeah. Now we're going to check the 8 directions. So for dr and dc in directions, we're going to prepare the row and column. It's going to be r plus dr and c plus dc. We don't need to check the boundary. Yeah, because it is said it is unlimited, and this x and y is a really small number, and we are calculating the sorted path. Basically, I think we can get the result. We don't need to control it from here. Yeah, we don't need it. Now we can start calculating. So if row and column not inside the weighted set, so we're gonna put it inside the weighted set. And for the queue, similarly, we need to put it inside the queue. So it's gonna be row and column and steps and step plus 1. Yeah, because it's gonna be consume 1 step. Now from here we can check if this r equal to x and c equal to y. It means we've already found the answer. We just need to return the step, and definitely we can find the answer. So this is why we don't need to have a final return. We can just return it from here. Yeah. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check. Yeah, as you can see, it works. And the time complexity is n squared. N is the length of the board. It is set unlimited, but actually this number is from here. Yeah, we can say it is 600. So 600 times 600, it's gonna still be a small number, n squared. So that's gonna be the time complexity. Thank you for watching. See you next time.